In this video, we're going to introduce the concept of variables, which are useful for beginner algebra students. While I work this out, I want you to notice and wonder how this number changes while I go across it. So our first direction is to write down a number. Well, let's start easy. We'll go with 5. Step 2 is to double that number. Well, we know that 2 times 5 is 10. Add 9. 10 plus 9 is 19. Subtract 3, okay. Well, 19 minus 3 is equal to 16. Divide by 2. 16 divided by 2 is equal to 8. And then subtract our original number, which is the number we wrote down in step 1. 8 minus 5 is equal to 3. Well, you might be asking, what's so special about this 3? And I can show you. Well, let's try this with another number. Say instead of 5, we chose 11. Doubled 11 is 22, added 9 is 31, subtracted 3 is 28, halved is 14, and 14 minus 11 is 3. And so it seems that we get 3 every time we do these directions. And we can double check that. Instead of using a proper number, we can introduce the concept of a variable. In this case, I'll use x as the stereotypical variable. This x can take the place of every number, any number or no number, and we use it to describe a family of equations, which are all equations that have the same basic properties. Well, if we double x, we get 2x. If we add 9, we get 2x plus 9 as the expression up to this point. Subtract 3, well, 2x plus 9 minus 3 is 2x plus 6. Divide by 2. Just like the distributive property, for multiplication, this division will distribute across both, so we'll get x plus 3, and you might see where this is going here. If we subtract out the x, we're left with 3. So why is it that it gives us 3? Well, the answer comes from these directions. We can see that there are some inverse functions in these directions. Doubling a number and halving a number in 2 and 5 respectively do the opposite of each other. So the x's in this situation haven't changed. Writing down a number is the inverse operation to subtracting out that original number later. And that's because we can think of writing down a number as starting from 0 and adding our number, and then we take our number and subtract it back out to get our 0. So 1 and 6 and 2 and 5 don't really change the nature of the problem. We're introducing in steps 3 and 4 another set of inverses. Addition and subtraction are inverse operations. So we're adding a constant 9, subtracting a constant 3, meaning that we will always have a positive 6 here in the middle, and positive 6 divided by 2, because it was not in this doubling earlier, means that we have a net change of plus 3.